And welcome back. As we go ahead and continue looking at classes, we're now going to start taking a deeper dive look at them and how we can actually start using some of these to create our own. So in order to do that, let's first go ahead and start with the math class to kind of take a look at some of the methods that it uses and use that to help us enrich our own classes that we're going to end up creating. So the first thing to talk about is that the math class has a bunch of methods in it. If you recall, we've seen the math class already in operation when discussing random numbers. We, of course, use math.random, and then we, of course, could pass in some parameters for that to be able to process. Now, the math class is not simply just limited to random. It also has several standard mathematical methods inside of it. So the class math, as you recall, is provided automatically, and so we don't have to use an import statement. So let's examine a few of these methods. Now, all these methods we're going to look at are static methods, which means you don't have to handle them a special way. We can simply say the class name math in place of that calling object. I don't have to create a math class to actually use them. So let's go ahead and look at first exponents. How do we handle exponents? Because up to this point we've done a lot of basic things with addition, subtraction, multiplication, division. But what about exponents? Well, there is a method that allows us to do it. So we have public static double pow, double base, double exponent. This, of course, will calculate that for us. This is going to return the base to the power exponent. So, for example, if I do math.pow 2.0, 3.0, it's going to return as 8.0. We also can do absolute value. So the way we set that up is public static double ABS, and then we pass in our argument. So what does that look like? Well, we can also do this with a float. Same thing with a long or an integer. However, we end up passing this in, it's going to get us the absolute value, and that's just math.abs. You pass in a number, and it's going to calculate it. So, for example, if I pass in -6 or +6, both of these are going to return 6 because that's, of course, the absolute value of both of those numbers. Now, what about minimum? All right, minimum is another common calculation we might need to find. And for this, we, of course, can pass in public static double min, double 1, double 2. So we're putting in two numbers. Or we can do this with a float, or a long, or an int. And again, as you might guess, we're doing math.min. And this is an example, we're doing 3, 2. So it's going to look at those two numbers, compare them, and return whichever one's the smaller, which in this case is 2. Similarly, we can use maximum, the same approach. And so you can see we have a double, a float, a long, and an int. Again, both of these are taking in two arguments, and it's going to calculate whichever one is larger. So if I plug in 3, 2, it's going to, in this case, return 3. Now, what about rounding? Well, we do have some methods for rounding to be able to handle it. So we have a public static long, and we have a public static int. And what it's going to do is simply going to round that argument. Now, you notice in here, we only have two methods, a long and an int, because remember, longs are simply just an integer that has more place values. But if you look, they're taking in doubles and floats, respectively. So why is that? Well, if you remember, when we round something, we're rounding it to the nearest whole number. So for example, 3.2 is going to become 3, 3.6 will become 4. We're not looking for a decimal number, so it's perfectly fine that we have a decimal value being passed in, and then we have a whole integer value coming back. Now, there is some special rounding that you can do, so if you want to be more specific, you can do a ceiling function, which allows you to round up. Here now, of course, we use a double here, and so we're going to round up to the nearest. So, for example, 3.2 or 3.9, both of these will come back as 4.0 because it's going to be the nearest whole number. And now you notice it is in a decimal value. So that's one thing to keep in mind here. The round function gives us a whole, positive or negative. And here we're getting that decimal value. So again, it's just something to kind of keep in mind here as you use these various functions. We, of course, have off the floor function, which, again, very similar to what we just saw with ceiling, only the difference is instead of rounding up, it's always going to round down. So 3.2 and 3.9 in this case would return 3.0. Again, another double type. Now, one that is really handy is, of course, a square root function. If you look at square root, it's a double because a lot of times when we calculate square roots, we're going to have a decimal type value. So if I have, for example, math square root 4, that's going to be 2.0. But if I try doing something like the square root of 2, then I'm going to get something like 1.41 and then on repeating till we run out of places that we can actually display. So this is, again, why we wanted to have a double here and not necessarily just an integer type. So it makes sense for us to have it. And double, of course, has more place values than a float, so it's much more inclined for what we're probably going to need it for. Now, there's also one other thing to talk about, which is the math constants. The class math does have two predefined constants. We have e and pi. So you can think of these as, of course, variables that are set in their value and we can't change them. The constant pi is used in calculations typically involving things like circles, spheres, and other geometric figures based around circles. So for our purposes, pi is approximately 3.14159, and obviously you can make that more precise and stuff like that, but just kind of understand that's what we're working with. And of course, the constant e is the base of the natural log system. And again, we're going to approximate that down to like 2.72. Now, if we want to use these constants, so let's say instead of me having to create a static called pi, I want to use this directly in my program. I can just precede that with the class name math and a dot, so math.pi. And I don't have to create a variable. We've done this in the past where we created our own pi variable, and you could still do that, but you don't have to because it already exists, math.pi. Same thing with e. You can do math.e, and that, of course, will get that value for you. And so over here in Eclipse, let's just go ahead and demonstrate some of that so we can see what that looks like. So for example, exponents. Let's just go ahead and have a quick print line statement here and say we're going to demonstrate exponents. And what we want that to do is, of course, use our math function. So I can do math.exponent, which is exp. You do see there are some other functions that are in here that we didn't talk about, but we're just going to use the exponent function here. We, of course, want to have that be one power to another power here. All right. Now, we don't want exp, even though you think exponents. Well, we actually want to use the pow function here because, of course, that's the thing that's actually going to calculate. Now, Eclipse is being helpful and saying num1, num2. That's exactly what I want to do. And that, of course, will demonstrate that for me. Now, of course, I'm going to want to do absolute value. So demonstrate absolute value. And let's go ahead now and do math.abs. And what we're going to pass in here, let's just pass in, num2 works good. We don't need to demonstrate this for both of them, but we can if we really want to. In fact, let's just go ahead and add that in math.abs of num1. So we have a nice good demonstration of both of those. And now let's go ahead and do a demonstrate minimum. And for this, we do math.minimum. As you can see, it pops right up here. Now, notice we do, of course, have options here. We have double, double, float, float. And if you're not sure, you can always just go ahead and try to have it fill that in automatically. And Java will do the appropriate conversion for you. Now, I'm going to go ahead and put this. I'm actually going to copy this guy here because we're just going to change this one thing. Instead of being math.min, we'll make this math.max. All right, now, of course, we can do our rounding function here. So I'm just going to go ahead and demonstrate rounding. And let's go ahead and do, we want to do math.round. Now I'm going to go back here, math.round. And what are we going to do? Let's just go ahead and do num1 for our purposes here. And for our ceiling, let's go ahead and copy and paste these in here. I'm going to put in here ceiling rounding. And let's make this floor rounding. All right, and then we're going to replace this math.round with math.ceil. That will give us our ceiling function here. And instead of .round, we'll make this our floor function. And then lastly, let's do our square root. All right, so we're going to demonstrate the square root. And let's do that one of num2 this time. Then I just have our displaying of our constants here. So let's, for our purposes, have num1 be, let's just say, a positive number, and num2 we could do a negative number, or we could do just two positives here. Let's actually just do two positives here just to see how this turns out. So let's just do 4, and let's do 2. All right, because we know that should give some nice easy numbers for us to see in action here. So hit enter. And oh, I forgot to actually display those. So we are, of course, getting our messages here. So we're displaying out. So I just need to add a system out of print line here. So let me just copy those real quick. And then we'll just go ahead and close those out with a set of parentheses. And let's give it a run. So now let's try again. We did 4 and 2. And so now if we kind of scroll back up here, we're going to say demonstrate exponents. Oh, I forgot to demonstrate that one. That's okay. We can go ahead and take a look at that in a second here. But we can see absolute value. We get 4.0, 2.0. Minimum is 2. Maximum is 4. Rounding, notice, is now just 4. There's no decimal involved in here. We have a ceiling, which is 4. This one is also 4 because, again, we're using num1 on both of those. Demonstrate square root, we got 2, because 4 take to square root is 2, and then we got pi and e. Now let's go ahead and just rerun this one more time. Let's just go ahead and do something with a decimal. So I'm just going to do 4.1, and let's do 2.2. Hit enter. And of course, you can see demonstrate exponents has now calculated that. And you can see our absolute value has been unchanged, minimum and maximum. Our rounding, though, we can start seeing some different changes here. So for example, with the ceiling, 4.1 has become 5.0. And with 4, it is now 4.0. And our square root, of course, you notice it's still 2. Right? And that's because of how that square root function is set up. But other than that gives us a nice, good demonstration of how this math class is used, and gives us some good things for us to be able to use as we start moving forward into making our own classes.